the vertical asymptote, that is where the fraction is undefined. All right, where the fraction is undefined. And what's undefined mean? I take whatever's in the denominator and figure out when it equals 0. I don't care what's in the numerator tomorrow. Don't touch it. If it looks factorable, don't touch it. Okay, so solving this, we end up with x equals -3. So that's where the vertical asymptote is, the vertical one. All right, so vertical, we would write vertical asymptote, x equals -3. And you can't just write -3 for me tomorrow. All right, if it's a non-multiple choice question, I need to see x equals -3. All right, horizontal, you guys got to remember the rules. I can't help you with that tomorrow. You've got to remember the rules. And the rules I'm talking about are where the degree is higher. So in the numerator, I just have the number 2. So we would say the degree is 0 versus on the bottom, what's my degree? 1. So now I have to remember the rule tomorrow, or the whatever you want to call it. When the denominator has the bigger degree, what is the y-intercept? When the numerator has the horizontal asymptote. If you got to look back in your notes, if the degree is bigger than the numerator, the denominator is bigger than the numerator, what do we say? It's either y equals 0 or none. It's going to be, what was the rule from Friday? I don't want to hand it to you. It's y equals 0, correct? But I threw in a little change up here. What's happening here? What's this -2 tell me? Everything goes down 2. So it wouldn't be y equals 0. It would be y equals -2. Am I going to do something that hardcore to you tomorrow? No. But look, you got to remember the 3 rules. If the numerator is bigger, if the denominator is bigger, or if they're the same. Got to know what to do in that case. All right, from here, if you know the asymptotes, you know the domain and range. All right, but that's why I asked for them first. If you know the asymptotes, you know the domain and range. So my domain, what's the domain related to? The vertical or the horizontal? Vertical. So the domain is x such that x cannot equal -3. Domain and vertical always go together. And then what would be my range? Y such that y cannot equal -2. They go with the horizontal. Okay, so get the vertical and horizontal done. You'll know the domain and range. And then finally, as long as you know what the heck you're doing, the y-intercept shouldn't be a big deal, because I'm going to go back to my graph and do what? Plug in everywhere I see an x, plug in 0. So you're going to do 2 over 0 plus 3 minus 2. And that'll end up being -4/3. The other way to do it, remember, is graph it. Okay, graph it, go to your table, and see where x equals 0, what the y value is. All right. I heard a couple people say, do I need to do this algebraically? The answer is no. But here's the problem you may run into tomorrow. What if there's 2 vertical asymptotes? And you're only searching for one on your graph and you have no idea that another one exists? That could be a problem if you just rely on your calculator. Okay, any questions here? How to find them. So first question tomorrow, I am going to just solely ask for vertical, but I think the last question on the test is find all 5 of these. All right, we're good. All right, simple. Here we go. Now I'm going to start rolling here. I just want to make a point on those. Okay, next question. Simplify by factoring. Okay, take a fraction, simplify it, simplest form. And guys, if I start seeing this tomorrow, I did you no good then. I did you no good this unit. If you just start crossing out stuff. You can't cross out unless you do what first? Factor. You have to factor first before you cross off. So here we go. What's our factoring ability like on top? That's perfect squares again. I don't want to waste time calling on numbers. +1, -1. And on the bottom, two numbers that multiply to 2, but add to 3. So x plus 2 and x plus 1. Cross off anything? X plus 1s can go. And I'm left with x minus 1 over x plus 2. That's as far as we can go. Again, I'm not saying it's exactly like that. There may be a different method to factor there, but that's what I mean by simplify. All right, adding now. Here we go. Adding or subtracting fractions. The one on the test tomorrow is adding. I don't have an addition one in your review. Here's a subtraction one. Same thing. Okay, same thing. Got to find a common denominator here. Got to find a common denominator. Are any of those denominators factorable? No. Nope. All right. What's in common? Oh, I knew you were going to do that. Remember, this x is attached to that -1. So there's nothing in common. Okay, there's no x in common because this is x minus 1. That's an x by itself. So there's nothing in common. So I put all the leftovers in, which would be what? X and then x minus 1. Now you go to each individual fraction, multiply by what it is missing. So first fraction, 3 over x minus 1. What's the denominator missing? And everyone see it's missing an x? So that's what I'm going to multiply the 3 by. 3x minus, hold on there. What's this x? What's this denominator missing?
X minus 1.
And what are you going to tell me here?
Negative.
Distribute? Negative 2, right? Not a 2, a -2. So you end up with minus 2x and plus 1. Yep. All right, combine your like terms. What do we have on top?
X plus 1.
An x plus 1. I did this one on purpose. Are those two opposites?
No.
X plus 1, x minus 1. Opposites? What's the sign on the x's here? They're not opposite. So no, they're not. They both have to be opposite. So there's my final answer. Next question on the quiz, horizontal asymptote, know the rules. Sorry, go next.
Why is it x plus 1 on the top and we distribute the 2?
Okay, you distribute a -2, right?
Yeah.
All right, so that gives me, ready? -2x plus
Plus 2.
Thanks. Yes, that gets me bitter. Not at you,
Oh, plus 2.
but at myself. All right, I'll get over it. A couple of problems probably. All right, horizontal asymptote, know your rules, right? Where's the degree bigger? What's the rule for it? And if the degree is the same, like if I had 4x squared plus 1 over 2x squared minus 6x, something like that. And I said, what was the horizontal asymptote for this one? Notice degrees are the same, right? So I say y equals, I divide the numbers out in front, so my horizontal asymptote would be y equals 2, if they happen to be the same. Okay, here's where I'm getting nervous tomorrow, is solve a fractional equation. This is where at the end, you should have x equals an answer or maybe multiple answers, right? This is the only different type of problem here that I'm going to give you where you need to find a common denominator for me tomorrow, all right? Because remember, you want to eliminate these denominators. You want to eliminate them. Common denominator, x and 5x. What do you think? Nothing's factorable. What do they have in common? Now they do have an x, yep. And what's left over? A 5. So there's my common denominator. But I am not going to do this. Not with an equation. That's when I needed to add and subtract up here. I put the denominator. Now I'm going to take the common denominator and multiply each fraction. Because look, what happens here? What's going to cancel? The x's, right? And you're just left with 2 times 5. No more denominator. This is the only time that happens is when I ask you to solve for x. All right? No denominators anymore. None. Do the same thing here. Multiply by 5x. What cancels? Everything. Plus 3, and don't do this to me tomorrow. Oh, equals 1. That doesn't make any sense, first of all. And you got to multiply everything by the common denominator, including the right and the left side. But does anything cancel here? Nope. And can you solve that? So 13 equals 5x. Divide both sides by 5. We'll just leave it as fraction form. I want to remind you, quick check. Go ahead, grab your numworks calculator. This might be good or bad for you, right? Because if you don't get what it says, we're in trouble. So I go over to equations, hit your home button, go over to equations, add an equation. So now I type in, remember how to get your fraction, hit your division sign, maybe once, maybe hopefully everyone once. If not, you might have to hit it again. And then I type in the exact equation it gave me. So 2 over x. What's it, plus or minus? Plus, thank you. Divided by, what do I have here? 3 over 5x. Remember the equals is right where the pi button is. Okay, so I got to go shift pi equals 1. You can press execute, it'll shade it in gray. And then I scroll down to solve the equation. It says give me a range to solve it from. Yep. Give me a range to solve it from. I always go from negative 100 to 100 because I highly doubt that the answers are going to be any smaller or bigger than that. And then solve the equation. 2.6, which is the fraction equivalent. Yep, Emma.
Yeah, I was going to ask for when you're putting in the answer for the final answer, can you put it in decimal form?
The only rule I have is as long as that decimal isn't sloppy and just goes on forever, like 2.6, completely fine.
Okay.
Yep. The only time I like it as a fraction is if it definitely goes on forever without any kind of pattern. Okay, so good way to check it tomorrow. Now look, I'll be honest with you. This is probably going to be a 5 or 6 point question tomorrow. If you have no work that matches the answer, because I know you went on the numworks and solved it, I'm only going to give you a point. Okay, so if you're happy with that, go for it. All right, if your work doesn't match how you got to the final answer because you checked it on numworks and just wrote it down, I'll give you a point, but that was about it out of 5 or 6. Any questions there? Okay, so again, solving an equation. I got to get rid of the denominators. That's the only time I get rid of the denominators. If I'm adding or subtracting, I keep the common denominator. Okay, if I'm adding or subtracting. Anything before we keep rifling on? Because I do want some time for you guys to practice. All right, factor an expression with 2 variables in it. I put it on there. Look at number 3 for me. That's all I want you to do, guys. Just factor it. I know you got the A and the B and it's scaring you. Ready? Any GCF?
No.
Nope, because that's where I always start. How many terms are there?
3.
3, and the number out in front? 1. So you can play your game of, ready? Multiplies to what? 12. Multiplies to negative 12, but it's got to add to positive 1 in the middle. Yep. You can play that game. Multiply to negative 12, but add to positive 1. Don't get freaked out by the B's. Anybody have 2 numbers that'll give me negative 12 and 1? Go ahead, Emma.
X plus 4 and x minus 3.
Okay, so I'll go plus 4 and minus 3. Is everyone all right with the numbers? And then I'll deal with the variables. Okay, it's got to be a squared though, right? So what's got to go in front? A and A.
Mm-hmm.
And then what's the only thing I'm missing though? Right? I need 12b squared. So where should the b's go? Next to the 4 and the negative 3. All right, don't get scared off by the multiple variables tomorrow. Just do multiplies to this, adds to this, and then add the extra variable in at the end. We're good? Okay, next topic on the test, what makes the fraction undefined? So look at number 12 or you got number 12, it's right in front of you. What am I looking at, undefined?
Equals 0.
What does? Because I threw something in here to tempt you. I want you to fall into the trap here. What do I only care about for undefined? Denominator. Don't look at the x squared minus 16. It means nothing to me in this problem because I'm asking for undefined. Go ahead and factor it, great, but don't do anything with it. I only care about this being equal to 0. Undefined, denominators only. Don't even look in the numerator. Cross it out, whatever you got to do. All right, what am I doing with this bad boy to figure out what x is? Factor it, yep. X. What do we have? Ooh, 2 new numbers that multiply to negative 12, but now add to negative 4. 6 and 2. What do I have? Negative 6 and positive 2. Are those my answers, though? No, those are called factors. Take them out now. Take them out of the parenthesis, set them equal to 0, and roll. So my 2 answers are going to be x equals 6 and x equals negative 2. Those are the 2 answers that'll make it undefined. If you remember, you can go to your calculator and how do I check an undefined one to see if those are really truly the answers? Store them, yep, store them in, and then type in the original problem, and you should get what when you hit enter? Big old error. Okay, what's up, Richie?
So when you factor those like in a different way, where like you only get one thing in parentheses, can't you only have one answer?
What do you mean factor it in a different way? Like how else would you like
if
it?
you took out a GCF.
Okay, so okay, let's go over that whole rule too. Good call. I know what you're talking about now. So there's a couple different ways. Ready? If I do take out a GCF that looks like this. Okay, let's say I took out a GCF and that's what's left. You're still going to have 2 answers. X equals positive 3 and x equals 0. Okay, versus, ready? Let's say I just take out a 4. You're right. I'm only going to have one answer here because it doesn't make any sense to set 4 equal to 0.
Yeah, that's
Okay. The last combination is what if I take out both? So let's say I take out a 5x. I'm going to have 2 answers. X equals 3 again. But now I'm going to set 5x equal to 0. Divide both sides by 5. There's my second answer. So the only time I'm going to get one answer taken out of GCF if it's just a number. Okay, if you take out some form of a variable, you got to have 2.
Yep.
What's up, Max? Go.
When storing and like
Yep.
checking your work, do you put in the whole thing or just the denominator?
No, whole thing. Whole thing. Yep. If you want to see the error message, whole thing. Anybody else? These are awesome. Great questions. All right, dividing. What do you got to remember with division before we even start anything? Skip and flip, right? Skip and flip. Oh, hopefully your factoring game's on here for this next one. Skip and flip, change it to multiplication, right? Because I think all 4 methods of factoring we talked about are present here. I know you're excited. Oh, don't do it, don't do it, don't do it. What are you looking at, top left? Thank you. Thank you. I was going to hear perfect squares. And they are. But you got to look for a GCF first, because what can you take out?
4.
A 4. Watch. I'll do it off to the side because I know what's going to happen. X squared minus 25. Now what do you see inside the parentheses? There's perfect squares. All right, so I need that 4 on the outside with plus 5 and minus 5. Yep. Now, hey, are you wrong if you did 2x plus 10 and 2x minus 10? It's not wrong, but what do you still have in each? A GCF you can take out. All right, and probably something's going to need to get crossed out, and you won't be able to see it be crossed out because you didn't take out that GCF first. All right, bottom. Numbers, ooh, that's always a tricky one. Numbers that multiply to -6 but add to 1.
3 and -2.
Woo. +3 and -2. All right, I'm going to skip the top right because that's the big dog. What do you want to do on the bottom right? GCF, right? Take out a 4. And I'm left with 5. Ooh, I sniffed something there. We'll talk about that in a second. All right, let's get to the big dog now, the top right. Anybody know what method's about to come up here? Grouping. Good job. Yeah, this is a grouper. All right, and a lot of people on the quiz just didn't finish the grouping method. You stopped in the middle on me. First step is, which will give you 20. The only thing that you are changing is the middle term becomes 2 terms. Nothing else is changing. So multiply to 20, but add to a -9 in the middle when you give me a. Multiply to 20, add to a -9 in the middle. -5, -4, perfect. I don't care what the order is, it won't affect it. And that's what happened. Some of you guys would do this on me on the quiz. X -5, X -4, I'm done grouping. That's not the grouping method. All right, that's just to find the 2 middle terms. All right, that's not the grouping method. All right, now you want to group them. Go ahead and group them. All right, let's see. What can I take out of this first one? A 2x. And be left with X -5. And make sure you're left with an X -5 again. So take out a. I don't know. I don't know how I took it out. I'm trying to invent some new math here.
I did 2x squared minus 4x.
Okay. We should both still get the same thing at the end, I hope. If I can do it right. 2x -5. And then over here you take out a -2. And also get a 2x -5. So no matter how you ordered it, how'd we do, Emma? X -2 and
2x minus 5.
there you go. Yep. So we ended up with the same stuff. All right, everyone's favorite time now. Crossout time. X -2s. They can go.
Can the 4s go?
Yeah, why not?
4s can go.
Yep, they're not attached to anything.
And then
'cause
the
they don't have
x minus 5 and 5 minus x.
And then let's talk here. X -5, 5 minus x. Yeah. Yep, because they both of them, the 5 and the x's have opposite signs, so they can go. But I got to be left with a -1. Yep. So now I regroup here. Figure out everything that's left over. So -1, if you just want to put the negative instead, fine. X +5, 2x -5, and then an x +3 on the bottom. I know we're probably used to a little bit more left over, but that's it. Now, all right, before I move on, do you see the importance at the beginning of taking out the GCF first? Because I don't have an x -5 if I do that. I don't have a 4 if I don't take out the GCF. That's why you got to look for GCF, as tempting as it might be. All right, I really want to stop talking here. Okay, solve fractional equations. We've gone over that already. Multiplying is the same as dividing. I guess we got to go over 12 complex fractions, huh? Remember with these, I need 1 over 1. Okay, because look in the numerator right now. How many fractions do I have here? 2. I need to make it 1. How many do I have in the denominator? Well, this is over 1, right?
2.
So technically I have 2. So both top and bottom, I need your help making it into 1 fraction each. So let's start with the top. What's your common denominator in the top? Anything factorable? Nope. Watch your mouth. Do they have anything in common? Nope, no x, right? That's attached right there, so nothing in common. So what's my denominators that are left over? X and x minus 3. All right. What's this? Look at this one here I'm pointing to. What's this one get multiplied by then? X, good work. So x squared plus, what's this 4 got to get multiplied by? X minus 3. So plus 4x minus 12. Don't do anything yet. Let's go to the bottom now. Nothing in common, nothing factorable. There is literally only one denominator other than the 1. And so what's my common denominator? Okay, what's the 1 have to get multiplied by? Look at the bottom. 3 minus x, yep. So 3 minus x on top. Does this fraction need to get multiplied by anything?
No.
So I'm just going to, everyone's comfortable, I'm just going to keep it minus 1. Okay, you can clean that up if you want, right? You can clean that up. We'll clean that up when I get to it. Okay, now what do I have to remember here? Skip and flip. This is division problem now. That's all this is. Fancy symbol for that one. So x squared plus 4x minus 12, x minus 3, times, flip it. I'll combine my like terms now, negative x minus 2. Or 2 minus x, negative 2 minus x if you want to do that. All right. Any other work to do here?
Yeah.
How did you get negative x minus?
Or plus 2?
Yeah.
Just 3 minus 1, Carlene. That's all it was. Jesus, 3 minus 1. What about, can I factor that?
Yeah.
Yeah, I can. Top I can, yeah. What are those two numbers there? Plus 6 minus 2. And here we're good. Here we're good. All right, let's watch our mouths here. What can I cross out?
You can do the two opposites.
Right. X minus 2, negative x plus 2. Are they definite opposites?
Yeah.
Opposite signs on both. So they're gone, but I'm left with a negative 1. Anything else?
3 minus x and x minus 3.
Those are also opposites. Everyone agree? So I'm left with another negative 1 to multiply. All right. So what's going to happen with those two negative 1s? Cancel. They'll turn into positive 1. So kind of got not even look at it. So what's left on top? And on the bottom, anybody want to cross off those x's? Get out of here. Get out of here. Okay, so there's a little complex fraction for tomorrow. And what else here? Okay, we did this at the beginning, right? Make sure you find these two first because they relate to domain and range. All right, so you do what you need to. Finish the problems we skipped over in there. Go to your review. Start those questions. You know where the answers are. They're under homework answers. All right, homework answers under classroom.